Yesterday we are talking about the uh, quantity of steel. Now, in many cases, the quantity of steel is also defined in a percentage way. In steel quantity defined in percentage basis. In some cases, the steel quantity is defined in a percentage basis. Now, when the quantity of steel is defined in a percentage basis, then how we are going to calculate that quantity that we are going to learn. Now, suppose 2% steel quantity is assumed. 2% of steel quantity is assumed. Now our task is to find out the quantity. Now when we are considering this is 2%, then this 2% is nothing but it is with respect to the quantity of concrete. So this 2% of steel is correlated with, so this quantity, this 2% is with respect to quantity of concrete volume. What? This 2% is nothing but with respect to the quantity of concrete volume. Now, quantity of concrete is 1 cubic meter. Quantity of concrete is 1 cubic meter. Therefore, volume, this quantity means volume. Okay. So, volume of steel is 2% of volume of concrete. 2% of volume of concrete. What exactly we are going to consider? Because this 2% of steel is related to the quantity of concrete, and we know that we are measuring the quantity of concrete in case of cubic meter. We are measuring the quantity of concrete in case of cubic meter. So 2% of volume of concrete. So therefore, so this becomes 2 by 100. And how much amount of volume of concrete you are going to assume? You are going to assume 1 cubic meter. So therefore, it is equals to 1. It is equals to 1. So therefore, this becomes 0.02 cubic meter. 0.02 cubic meter. Now, this is the volume of steel, but we are measuring the steel quantity in case of kg or metric ton. We are measuring the steel quantity in case of kg or metric ton. So now it is necessary for me to convert this volume into the kg. So I know that the density of steel is 7860 kg per meter cube. 7860 kg per meter cube. Therefore, quantity of steel in kg, is equals to what? Is equals to density of steel multiplied by volume of steel. Density of steel multiplied by volume of steel. Now, what is the volume of steel? The volume of steel is equals to 0.0. Sorry, density of steel 7860 multiplied by volume of steel 0.02. This much kg. Tell me the answer.
$157.2.
सर can you repeat एक बार क्योंकि अभी ज्वाइन हुआ है नहीं
Hello. 157.2. 157.2 kg. 157.2 kg still required for 1 cubic meter of concrete. 1 cubic meter of concrete. Clear? So this is the calculation point of view. Now suppose if quantity of concrete is equal to say 15 cubic meter, quantity of concrete is say 15 cubic meter, and steel consumption is suppose 2%. Instead of 2%, suppose 1.2%. Suppose 1.2%. So now our task is to find out the concrete quantity. Our task is to find out the steel quantity on the basis of this. Now we know that quantity of steel in kg. Quantity of steel in kg is equal to what? Is equal to density of steel multiplied by volume of steel. Density of steel multiplied by volume of steel. Now we know that the density of steel is equal to 7860 multiplied by volume of steel. What is the volume of steel? It is 1.2% of quantity of concrete. 1.2% of quantity of concrete. So therefore, this is 1.2 divided by 100 multiplied by 15. Multiplied by 15. What is this? This is nothing but the volume of your steel. This volume is multiplied with density. So you will get the quantity in kg. You will get the quantity in kg. How much? It is 1414 kg. So 1414 kg. Clear? So therefore this becomes 1.414 metric ton. 1.41 metric ton. So 1 metric ton is equal to 1000 kg. 1 metric ton is equal to 1000 kg. This is the simple fundamental we are going to utilize. So many times people are giving you the quantity of steel in the basis of percentage. Now on the basis of that percentage, your task is to find out the volume of steel. Once you get the volume of steel, that volume of steel multiplied with density, and you will get the quantification. In this way, we are going to do the calculation. Is it okay? Please speak. यहाँ पे speaker लगा हुआ है.
हेलो सर, हेलो, आवाज आ रही है?
Okay.
हेलो
Now.
एको भी हो रहा है क्या? सबके इसमें एको हो रहा है क्या? थोड़ा थोड़ा
सर ने ब्लूटूथ नहीं पहने इसलिए थोड़ा हो रहा है.
Now, today we are going to see the second method, that is called a center line method. No, you are not audible to me. Okay, fine. Anyways, now we are considering the second method, that is center line method. Center line method. Now, as I said, there are two methods. First one is center line method and second one is long wall, short wall method. These two methods are utilized in case of your load bearing structure. Now, what exactly this center line method is and how this center line method is going to be worked out, that we are going to see. Now, first step in case of center line method, there is no short wall, there is no long wall or short wall. There is no any kind of long wall, there is no any kind of short wall. Simple, we are going to do the addition of center line of each wall. So do the addition of center line of each wall. Center line of each wall. Now, when we are saying we are going to add आवाज आ रहा है नहीं आ रहा है
Hello, sir. Hello.
Okay, just a minute. Okay, now it is fine. Now see, in case of center line method, what exactly we are going to do? There is no any kind of short wall, there is no any kind of long wall. Then second parameter is there is an addition of center line of each wall. There is an addition of center line of each wall. But when we are going to do the addition of center line of each wall, when we are going to do the center line addition of each wall, then remember one thing, the thickness of wall remains same. So we are going to do the addition of center line of each wall when thickness is equal. When the thickness is equal, then and only then we are going to do this kind of addition. Now, we are going to understand this concept. This is one room structure plan. This is first center line. This is second center line. Third center line. And fourth center line. There are four center lines are there. Now, suppose this length is L1, this length is L2, this length is L2. Now, understand this thing. Now, we are going to calculate the area of this plan. We want to calculate the area of this plan and then we are going to multiply it by height and we will get to quantity. That's a simple thing. But the main thing is how I can calculate the area of this particular figure on the basis of the center line method. Now in this method, what we exactly do, we are considering the center line to center line. It means that suppose the width of wall is B. Now I want to calculate what? I want to calculate the area of all the panels. Now how I am going to calculate the area of all the panels on the basis of center line? See, for wall number 1, for say wall 1. Suppose this is wall number 1. Suppose this is wall number 1. How I am going to calculate the area? I am going to calculate the area is equals to L1 multiplied by B. L1 multiplied by B. Now when I am going to see L1 multiplied by B means what? I am going to consider this particular area. I am going to consider this particular area. Which area? This area.
So can you please repeat?
Area between two center line. So this area I am going to consider. This area I am going to consider. Are you clear? Yes, this one. Is it fine? Because I am considering my L1 into B. Now second. See, there are many issues. पहले तो class late हुआ. Anyways, I will let you understand what exactly I am going to do in this case. This is center line method. Center line method means we are going to draw the center line for each wall. After drafting center line for each wall, we are going to do some kind of assumptions for the calculation of area of this particular wall. I am just calculating the wall area, then I will multiply it by the height. I will get the quantity of wall. But the first task is to how I am going to calculate the quantity of area of that particular wall. ये जो wall है इसका मैं area कैसे calculate करूँगा? मैंने long wall short wall method से तो देख लिया. Long wall में add कर देंगे, short wall में minus कर देंगे, then we will get the thing. Same thing we will get through the center line method in a very simple way. To understand this concept, what I am going to do? First, I will draft the center line for each wall. I am going to draft the center line for each wall. So this is the center line for this wall. This one is center line for second wall. This one is for third. This one is for fourth. That's it. And those center lines are to be intersected with each other. Those center lines are intersected with each other. This is the point of intersection. Now, my task is what? I want to calculate the area of this complete unit. Means from this point to this point, I want to calculate the area. Is it okay? यहाँ तक clear है? I want to calculate the area of this complete unit from this to this. Is it okay? Now, to calculate this area, what I am going to do? I am going to do L1, that is center to center distance between this to this, and this L1 multiplied by the B. L1 is multiplied by B. When L1 multiplied by B means how much area you are going to consider? You are going to consider from this point to this point. With this width B. So therefore this portion I match. It is okay.
Yes, sir.
This is the first point. Clear? You are going to calculate area between two center lines. Now second, listen this. Now suppose if I want to calculate for next wall, suppose this is wall number 2. This is suppose wall number 2. Now I want to calculate the area of this wall number 2. How I am going to calculate this area for wall number 2? See, I will consider the center to center distance. So wall number 2 is equals to center to center distance is L2. And the width of wall is B. So therefore I will multiply by B. Now, which portion it is going to cover? This covered this portion. Means center line of this and center line of this. Now, if I add this portion, So this area I'm going to get. Is it okay? Yeah, the clear.
Yes, sir.
Please listen. This is most important concept. Is this okay? Means in first case, this is the area. In second case, this is the area. Fine. Now, see that this corner portion, this portion, means if you draw the long view, then I will draw the larger view. So this portion is hatch and this portion is again hatch. But this portion is remaining. But this portion is remaining. This corner portion is remaining. But now you can see that ये जो portion है, this portion, this is repeated twice. This is repeated twice, and this portion is not repeated. This portion is not repeated, which should be there. Which should be there. So what happened? These two portion, they are counterbalanced with each other. They are going to counterbalance with each other. Are you okay? समझ में आ रहा है? What exactly happened? See, this particular patch, suppose A, and this particular patch is B. Now this patch A means ये corner. This is repeated twice in your calculation. But this B means corner portion is not repeated at all. But area of A is equals to area of B. Means this patch and this double patch have the same area. When these two have the same area and A is repeated twice, it means that they are counterbalanced with each other. What do you mean by counterbalance with each other? It means that this complete area is already taken for consideration. It is okay. Same way, when same rule is applicable over here, because same wall is there, same wall is there, same line. So what happened? This area is hatched in this way. And same area is on this side. So this portion is again hatched. Now in this complete figure, these corners, this corner number 1, corner number 2, corner number 3, and corner number 4, these 4 corners does not consider in your hatch portion. It is okay. Why they are not considered? Because we are considering between center to center distance. Again, in y direction wall, we are considering center to center. So what happened? These corner portions are not considered in the hatch portion. So whether we are going to add the area for this unhatched portion, we are going to think. Now my answer is no. Why we are not necessary to add the area of this unhatched portion in your calculation? Because this unhatched portion corner, listen, this unhatched portion corner is counterbalanced by diagonally opposite corner. Because what happened? This portion is repeated twice. ये जो portion यहाँ पे छोटा सा form हो रहा है, ये आपका ट्वाइस फॉर्म हो रहा है. सो ये ट्वाइस हो रहा है, ये नहीं हो रहा है, इसका मतलब दे आर काउंटर बैलेंस विथ ईच अदर. They are counterbalance with each other. So there is no necessity to calculate the things. Now, if I want to calculate, this is wall number 3, this is wall number 4. If I want to calculate the area of this, then what I have to do? Area is equal to L1B plus, what is L1B plus, this is L2B plus, this is again L1B plus L2B. This is L2B. So char wall at B. Now take B common. So if we take B common, then this is L1 plus L2 plus L1 plus L2 into B. Into B. Now what is this L1, L2, L3? What is this L1, L2, L3? These are the center line of what? These are the center line of what involved in that calculation. So L1 plus L2 plus L3 plus L4. This is nothing but the summation of center line. So this L1 plus L2 plus L1 plus L2. This is nothing but it is a summation of center line of all walls. Center line of all walls. Do you understand the concept?
Yes, sir.
Tell me frankly. Next time we will once again repeat on next class one. Exactly what happened. See, the basic fundamental is this portion is repeated twice. Draw करके देखो. This portion is repeated twice. This portion is not repeated, but they are counterbalance each other. Same thing is happened over there. This corner is repeated twice. And this corner is not repeated at all. So they are counterbalanced with each other. Same way, this portion is repeated twice and this portion is not repeated each other. So they are counterbalanced each other. Same way, this portion is repeated twice, but this portion is repeated. Sorry, this portion is repeated twice, but this portion is not repeated at all. So there, this is twice, no part in calculation. So they are counterbalanced with each other. So this is the basic fundamental of this center line method. Now in case of center line method, there are two corrections. Now in this case, the wall is joining in this way. Means there is a L corner. So in case of L corner, there is no any correction. Why there is no any correction? Because this is repeated twice, this is not repeated, so they are going to counterbalance with each other. But what about when you wall? Wall कैसे आ सकती है? So there are corrections. In case of L corner, there is no necessity to have any kind of correction because this corner is L corner, this corner is L corner. L corner means two walls are intersecting with each other by the 90 degree. This is again L corner, this is again L corner. Now a second point. If this is the wall and second wall is going in this way, second wall is going in this way, it means that this is a T wall, this is a T wall, the center line of this, and this is the center line of this. This is T wall. Second, there is a cross wall also. Cross wall means center line of this wall, center line of this wall. So we have to do some kind of correction for this T junction and this cross junction. T junction and cross junction. This is called as T junction. This is called as cross junction. This is called as cross junction. So it is necessary for us to do the correction for T junction as well as the cross junction. What are those corrections? We will see next class. What are those corrections? We will see next class. It is okay till this point. Do you understand this concept?
Yes, sir. Got it.
Tell me frankly. Now in same problem, whatever the problem we have considered previously, same problem we will solve through the center line method, and you can see that within one calculation you will get the answer. Within the single calculation you will get the answer. In case of long wall, short wall, you have to do the 8 to 10 number of calculations, then you will get the answer. But in this case, you will get the answer in a single calculation. So okay, in tomorrow's class we will see what are the corrections for cross joint, what are the corrections for T joints. Right now there is no any kind of correction in case of L joint. There is no any kind of correction in case of L joint. इसके अलावा और कोई joint आ सकते हैं? These are the two joints which generally happen in case of three joints, T, L, and cross joint. This three joints are always there in case of your construction. So thank you. If you have any doubt, you can ask. Attendance, रोहन जो प्रेजेंट है उनके स्क्रीनशॉट ले लो एंड शेयर विथ मी, दैट विल बी द अटेंडेंस. ओके, जो अभी प्रेजेंट है उनका स्क्रीनशॉट ले लो. ओके, सो थैंक यू. आज लेट इसलिए हुआ क्योंकि डिपार्टमेंट खुला नहीं था. एंड सेकेंडली आवर क्लास इज फ्रॉम 9 to 9:45 onwards.